Example 5. Find a formula for f inverse and give the domain and range of both f and f inverse. Then sketch both functions on the same coordinate axes. The function here is f of x is equal to x squared plus 1, and then we're told that x has to be greater than or equal to 0. All right, so example 5 is laid out just like example 4 was. We have our grid because we're going to find f inverse, and then we're going to graph the original function f and f inverse on the same grid. And then if you will see a place to jot down both the domain and range of f and the domain and range of f inverse. Okay, I'm going to start this just like I did example 4. I'm going to first deal with the original function. I'm going to graph it, write down its domain and range, and then I will come back and deal with the inverse function. Okay, all right, so here we go. Let's graph it first. The original function is x squared plus 1. This is, you can graph this easily through a transformation. So if the parent function here is x squared, which is a parabola, and then if you're adding 1 to it, you're adding the 1 outside of parentheses. There's no parentheses, so you're just lifting the whole thing up 1 unit. So if you remember, x squared, the parent function goes through 0, 0, 1, 1, 2, 4, and then 3, 9. Okay, and then it's symmetric about the y-axis, so it also goes through negative 1, 1, negative 2, 4, negative 3, 9. Okay, but that's the parent function. These are points on the parent function x squared, but now we need to plus 1 it, so we need to lift it up 1 unit. Each little x you're going to lift up 1 unit. Okay, so I'm going to do that, and then we will have the final points on the graph of x squared plus 1. Okay, so here we go. I'm going to go back in here and I'm going to erase these little x's because we don't need them anymore. So here is our here is our original function f. Okay, again, it's the parent function x squared, just lifted up 1 unit. Okay, so let me go ahead and draw this in. All right, so here is the original function. All right, okay. Maybe not. Maybe you have alarm bells going off in your head. Okay, there's a problem here. You may not have thought about it. This does not pass the horizontal line test. Okay, clearly, if I try to draw any horizontal line here, okay, it's going to intersect this parabola in more than one spot. Okay, remember, in order for something to have an inverse, it has to be a one-to-one function. Okay, so what do you do here? You might be like, okay, I'm going to throw in the towel. We can't do this problem. It doesn't have an inverse. Because remember, not every function has an inverse. Well, there's something we didn't pay attention to. Okay, out to the side, they told us the parabola can only exist for x values greater than or equal to 0. Okay, so what that means, okay, I'm going to erase this line here. What that means is that exactly what it says. The parabola can only exist over x values 0 or bigger. Okay, it can only exist over positive x values. Okay, so as a result, I'm going to go in and erase the left side of the parabola. Okay, now this is where the parabola is going to start at x equals 0. Okay, it's going to start at 0, 1, that point, and then it's going to exist to the right over the positive x-axis. Okay, if we erase that left side of the parabola, what's left passes the horizontal line test. Okay, so this is going to be invertible. Okay, it will have an inverse. Okay, had you not had that little stipulation there that the x values have to be greater than or equal to 0, then you would have been left with a function that does not have an inverse, or yeah, a function that does not have an inverse. Okay, so watch out for little conditions like that. They're very meaningful. Okay. All right, so here's the graph of the original function. It's the right side of that parabola. Okay, we can go ahead and write down the domain. Okay, this is a parabola, which is a polynomial. Normally the domain would be all real numbers, but we're told that the domain, which is the x values that this thing can exist over are the x values 0 or bigger. Okay, this is something called a restricted domain. The domain is supposed to be all real numbers, but in order for this function to have an inverse, the parabola can only exist over x values 0 or bigger. Okay, so the domain is going to be from 0 included to infinity. Okay, as soon as we write this down, okay, we know without even finding f inverse that the range of f inverse is going to be the same thing. Okay, don't even waste your time trying to find the inverse right now. Okay, you know this information without having found the inverse. Okay, domain of f will always be the same as the range of f inverse. Okay, and then we can look at our graph. Okay, to get the range of the original function f. Okay, find the lowest point on your graph. The lowest point on the graph here is 0, 1. Write down the y value. The y value is 1. This is a closed circle, so we're going to include it. Okay, and then the highest point on the graph, well, it continues to go up, 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 up forever, so the highest point is going to be infinity. Okay, so this piece of the parabola covers y values from 1 to infinity. Okay, and again, as soon as you write this down, the range of f, it's going to be the same thing as the domain of f inverse. Okay, so we can go ahead and fill this out without having even found f inverse yet. You know its domain and its range. Okay, all right, so now we're going to go ahead and find the formula for f inverse. Okay, so let's follow our steps. We're going to go back to our original function. We're going to replace f of x with y. That's going to equal x squared plus 1. Okay, and we're going to solve this, or sorry, I went ahead and I replaced f of x with y. Okay, now I'm going to switch x and y. Okay, so we're going to get x equals y squared plus 1. Now we're going to solve this for y. Okay, we need to get y by itself on one side. Okay, all right, so we're going to subtract 1 from both sides. Okay, and so we're going to get x minus 1 is equal to y squared. Okay, so I'm going to come up here. I'm just going to switch. I'm going to put the y stuff on the left and the x stuff on the right. Okay, so we've got y squared. We want y, so to get rid of the y squared, we just need to take the square root of both sides. Okay, so I'm going to take the square root of this side. Whatever I do to one side, I have to do to the other. On the left, the square and the square root will cancel, leaving you with y. Y is going to be equal to the square root of x minus 1. Okay, we have solved for y. Okay, so the last step will be to replace y with the f inverse of x notation. Okay, the inverse function is going to be the square root of x minus 1. Okay, so here you go. This is going to be the inverse function. Okay, all right. Okay, so we're going to go ahead and graph this guy on the same grid. Okay, so this is another parent function in transformation. Okay, so here the parent function is the square root of x. Okay, that goes through 0, 0. It goes through 1, 1. It goes through 4, 2. And it goes through 9, 3, if you recall. And then if we have a minus 1 underneath the square root, remember the square root acts like parentheses. So if you're subtracting 1 in parentheses, that means you're going to shift this right 1 unit. Okay, so we're going to take each of these x's and shift them right 1 unit. Okay, and I'm actually putting this in the wrong color. I said I would keep it color coded. So let me put this in red. Okay, so we're going to take each of these x's and shift them right 1 unit. Okay, and let me get rid of the x's now. Okay, so we're going to connect these red dots with the same basic shape as a square root function. Okay, so it's going to start here at 1, 0, and it's going to go off like this in this direction forever. Okay, this is the graph of f inverse. Okay, if you notice, okay, if we draw in our trusty line y equals x, okay, it looks like this. I'm trying to get it on here very accurately. Okay, again, that's the line that goes through 0, 0, 1, 1, 2, 2, 3, 3, and so on. Okay, if you were to fold a sheet of paper along the black line, the blue graph will lie on top of the red graph. Okay, they are mirror images of each other about this line. Okay, you can check it out. Okay, if you compare points on the blue graph to points on the red graph, okay, On the blue graph, I already have 0, 1 on there, okay? If you switch x and y, 1, 0, it's on the red graph, okay? If I look at the next blue point, okay, at 1, 2, okay? Switch your x and y, okay? You should see 2, 1 on the red graph. There it is, okay? And I'll check out the remaining two emphasized points here. So 2, 5 is on the original function, okay? Switch it. You should see 5, 2 on the inverse. Here it is, right there. Okay, last point I'll check. 3, 10 is on the original function f. If we switch x and y, 10, 3 should appear on the inverse function, and it does. Okay, everything should agree here. Okay, all right, we basically have all the information we need. Okay, we've graphed both the original function and its inverse. We have the formula for the inverse. We even have the domain and range of both f and f inverse. Okay, there is one other thing I want to say. Okay, we read the domain and the range. We got that from the information we had about the original function f. Now that we have a formula for f inverse, we can kind of check our work. Okay, here is the formula for f inverse, the square root of x minus 1. Okay, this is where this whole class starts coming together. You know how to find the domain of a formula like this. This is a square root function. So you need to take what's underneath and set it greater than or equal to 0 and solve. Okay, that tells you that the x values have to be bigger than or equal to 1. So the domain of the inverse function is going to be from 1 to infinity, including 1. Okay, that agrees. Everything agrees. Okay, and then once we had the graph of f inverse, we can write down its range. Okay, if you look at the red graph, the lowest point on this graph is 1, 0. That has a y value of 0. Okay, it's a closed circle, so you include it. And then the highest point on the graph, the red graph climbs very slowly, but eventually the highest point will be positive infinity. Okay, and we already had that down. That agrees with our prior work. Okay, all this stuff needs to agree. Okay, so there's lots of different ways to do little checks on yourself.